Hello everyone, welcome back to my additional mathematics channel. For today's lesson, I will focus on the linear motion, or we call as motion along the straight line. This topic is actually related to calculus and quadratic function. So let's get started with the class now. What is displacement? Displacement is actually refer to the reference point we call as fixed point. So now let's say we measure the distance from fixed point O is 3 meters to the right. When we talk about direction, it becomes displacement. So when we talk about magnitude, it's distance. So for the blue particle is displaced to the left, which is -1 meter, and for the red ball or red particle is actually 3 meter to the right, which is positive 3 meter. So displacement, it comes with the direction. It's a vector quantity, right? So when we say a particle displaced to the right from the reference point, it will be positive. Left will be negative. Okay, we always refer to the fixed point. A particle moves along a straight line from a fixed point O. The displacement of the particle s meter from O at t seconds after passing O is given. So normally we will use s to represent displacement, right? So it's given displacement in terms of function t squared minus 3t, and t between 0 to 4. So when t is 0, we will substitute. So s is equal to 0 squared minus 3 times 0, so we'll get 0. It means what? It means that the particle is starting at the initially is at the fixed point O, right? t0. Okay, so that is the starting point. Okay, when t equal to 1, where is the particle being displaced to? So when we substitute, we will get s is equal to 1 square minus 3 times 1, we get -2. It means the particle is moving to the left of the fixed point O, right? When t is 1. Okay, at t equal to 1, the particle is displaced to -2 meter, which is to the left of the fixed point. When t equal to 2, let's substitute again, and we are getting the s, which is -2. That means the particle is moving to the left again, which is now the particle is at -2. Okay, that means when t equal to 1 and t equal to 2, the particle is at the same place. It means the particle is actually turn the direction, right? So it go back to the same place. So when t equal to 3, we substitute, we get 3 squared minus 3 times 3, we'll get 0. That means the particle actually passes through the fixed point O again. Alright? So that is the movement of the particle. When we check the displacement, we know how to trace the particle, the position of particle at t equal to 4 is 4 meter. Now it seems like it is moving to the right 4 meter from the fixed point O. So when we are getting positive value for the displacement, it means the particle is moving to the right. So that is how the movement of the particle from t equal to 0 to 3 equal to 4. So between 0 to 4 seconds, inclusive of 0 and 4, we can actually say that particle is moving in such a way, right? So this is how the particle move. So by using displacement, we can actually monitor the movement of the particle of the ball for every moment. That is why we say instantaneous. Okay, instantaneous means that we can actually monitor for every moment or every second we can monitor closely the movement of the particle. So it starts from t equal to 0, 1, then turn back, passes through a fixed point, then it will stop at t equal to 4. So a particle moves along a straight line from fixed point O. The displacement of the particle as meter. So we can say that if O is a fixed point and the movement of a particle to the right of point O is positive, and the displacement is negative if s less than 0, which is a negative value when x less than 0. So it means what? The meaning is the particle is on the left of the reference point, okay, of the fixed point. So what it means by the displacement is 0. So when the displacement is 0, it means that the particle is actually on the original point of fixed point O, okay. So the displacement is positive, means that the s will be more than 0. Its meaning is the particle is on the right of the point O, okay, reference point. So you must understand the concept first before you can proceed, okay, to the solving problem for the displacement of the particle in terms of the function of t. So let's see the example 1. A particle moves along a straight line and passes through fixed point O. That is very important keywords. The displacement as meter of the particle t second after it starts moving is given. So normally they will give you s equal to how many t's. That is so-called function s in terms of t. So calculate the instantaneous displacement. So we will substitute the t0 into the s, alright, and then we will find the displacement, and that displacement is called as instantaneous displacement. So for t equal to 0, s is 4, and then for t equal to 10, s equal to negative 16. Therefore, the particle is located 4 meters to the right of the fixed point O for t equal to 0, and therefore for the B, the particle is located 16 meters to the left of the fixed point O when t equal to 10. Alright, so the positive and negative is actually telling us the position of the particle, right? Alright, so let's proceed to example number 2. A particle moves along a straight line and passes through a fixed point O. Its displacement as meter t second is given by s equal to 4t minus t squared. Okay, now represent the displacement of the particle by using the number line. So we have to list out the time from 0 to 5. It's inclusive of the 0 and 5, right? Should be inclusive. So when t is 0, we substitute, we get 4 times 0 minus 0. So we get 0 for the displacement. When t is 1, we will get 4 times 1 minus 1 square, which is 3. And 2, we will get displacement is 4. And 3, we get displacement 3. And 5 is negative 5. So we are going to draw a line, a straight line, because this is moving along a straight line. So let's see how we notice that at the t equal to 1 and 3, the particle is at the same place. So let's label the 3 first, and then at t equal to 4, the particle actually go back to the fixed point. At t equal to 5, the particle is at the left, right? Okay, so let's label according to the left, according to the right. At 2 seconds is at the 4 meter. So now let's see, at the t equal to 0, the particle is at the original point. So let's start to show how the movement of the particle. At t equal to 1, the particle moving to the right. Okay, let's show. This is the displacement, 3 meter to the right. And then at t equal to 2, the particle is actually travel to the 4 meter to the right. And actually that is so-called the maximum displacement. At t equal to 3, it actually go back to 3 meter from the fixed point. So, and now at the t equal to 4, the particle actually passes through the fixed point O, right? It passes through the fixed point O, and then it will actually go to left, which is at the negative 5 meter, okay, 5 meter to the left when t equal to 5. So that is actually the instantaneous displacement of the particle from t0 to 5. So it shows that how the particle move. Alright, so that is actually the real concept when we use a straight line. Now let's say we want to represent using the graph. So we have two ways of representation. One is we use the straight line because the particle move along the straight line. Now let's use the same table. Now we're going to sketch the graph. When t equal to 0 is actually the intercept for the s. So we will plot the point, right? The s meter is actually showing the displacement. Okay, so we will actually plot the point first. When t0, if the starting point is 0, when t equal to 4 is also at the displacement 0, so that is actually the intercept. We call it y-intercept, but it's actually the displacement equal to 0. So we are getting a N shape because the particles is actually having the maximum displacement, right? And the function is a quadratic function. When t equal to 1, the displacement is 3. When t equal to 2, displacement is 4. That is actually the maximum displacement. And then when t equal to 3, we get displacement the same with 3 again. And when t equal to 4, the particle is actually passes through the fixed point. And when t equal to 5, the particle is actually at the negative 5 meter, right? So actually the particle move from time to time, follow the direction, right? So if O is a fixed point and the movement of particle to the right of fixed point O is positive, then the displacement is negative, right? If the S is having less than 0, so the particle is on the left of point O. Okay, the velocity is negative. The velocity is negative. V less than 0. The particle move to the left. Okay, the particle move to the left when V is less than 0. The acceleration is negative, a less than 0. When we talk about a less than 0 means the velocity is decreasing with the time. When the displacement is 0, it means what? S equal to 0. It means that particle on the point O or fixed point, the velocity is 0. It means the particle is actually stopped instantaneously, or we call it stationary or stop, the same meaning. When the acceleration is 0, a equal to 0, what is the meaning? So it means that the velocity of the particle is either maximum or minimum, right? So when dv dt equal to 0, what it means by dv dt is actually changing of velocity with respect to time, which is acceleration. So when acceleration is 0, the velocity is either maximum or minimum. Alright, because the acceleration is the changes of the velocity with respect or compare with the time, right? So these are very important physics concepts that you must master before you can solve the problem involving kinetic linear motion. Alright, so basically all these important keywords you need to go through. So the velocity is actually maximum or minimum when it's something to do with the acceleration equal to 0. Okay, so the particle actually is moved to the right when the velocity is positive, or we call as more than 0, and when the velocity is actually less than 0, particle move to the left. When the acceleration is more than 0, means the velocity is increased with the time, and if it is negative, means that it will be decreased with the time. So for this example, a particle moves along a straight line and passes through a fixed point O. The velocity v meter per second after passing through the point O is given by the function v. So the v is actually given equal to velocity equal to 3t minus 12. So now you need to find the initial velocity. So initial velocity means t equal to 0. So we substitute. So the velocity is 3 times 0 minus 12. So the initial means the time 0. So the velocity is negative 12 meters per second. So when the instantaneous velocity, when t equal to 5, we will just substitute. So 3 times 5 minus 12, we get answer is 3 meters per second. Alright, so what about the time in second when the instantaneous velocity is 6 meters per second? So we will just substitute. 6 is equal to t minus 12. 3t minus 12 equal to 6, so 3t equal to 18. So t is equal to 18 divided by 3, so we get answer which is 6 seconds, right? So it's quite simple. So for B, we need to sketch the graph for the velocity and the time. So since the function is actually it looks like linear, it's a straight line, right? So it's actually a straight line. So we will substitute when t0 is negative 12. When t equal to 5, we'll get the answer which is 3. So we can plot a straight line to show that it's actually the graph for the display velocity with respect to time, right? So sometimes the graph is a linear one, and sometimes it's a quadratic, right? It can be cubic also. So let's plot the point first before we can draw a straight line. Okay, in order to draw a straight line, we just need any 2 points, and we will use a ruler to connect the 2 points, and then we will get the line that represent the graph, okay, for the movement of the particle for this question, which is velocity with respect to time, right? So basically we will actually just label v equal to 3t minus 12, right? Okay, so you can find the intercept x and y, and the gradient is positive. Okay, so let's discuss example 4. A particle moves along a straight line and passes through a fixed point O. At t seconds after passing through, its acceleration in meter per second is given by A is equal to 12 minus 4t. Acceleration is given. state the instantaneous acceleration in meter per second of the particle when t equal to 7. Okay, this is very simple. We will just substitute t equal to 7 and we will solve the acceleration, which is so-called instantaneous acceleration, is negative 16 meter per second. Let's discuss the self-practice. 8.1. A particle moves along a straight line, passes through a fixed point O. Its displacement in meter is given by s equal to 2t squared minus 5t minus 3. So we are going to solve. A. Find the instantaneous displacement in meter of the particle when t equal to 0. After we substitute, we will get negative 3 meter, and for t equal to 2, we will get negative 5 meter. Find the time when the particle passes through the point O. When particle passes through the point O, the displacement is equal to 0, right? So then we will let the 2t squared minus 5t minus 3 equal to 0, and we will factorize and find the t. So based on the logic sense, we will choose a time which is positive, right? Logically, we don't have negative in terms of time, right? Negative value we don't have. For number 2, if the displacement is 9 meter to the right means it's positive 9. So then we will substitute displacement equal to 9 into the s. So after we substitute, we need to factorize, right? Okay, after we factorize, before we factorize, we must make sure it's in general form. We have 2t squared minus 5t minus 12 equal to 0, and then we will factorize and we let the factor equal to 0, and we will find the answer which is positive. So the answer is t equal to 4, right? Which is positive value. The particle is at the right of the point O. Okay, so let's proceed to see when the particle is at the right of the fixed point. It means the s must be more than 0. So when the s more than 0, we have 2t squared minus 5t minus 3 more than 0. It means that we need to solve the quadratic function, right? So we will solve the quadratic function. We will get the range of the t, right? So do you still remember how to solve the quadratic function? You have to sketch a U shape, and then you have to choose the side whereby the function is above the t-axis. We don't have x. It's just like your quadratic function, right? You learn in form 4. Okay, so this is actually more than 0. That means the time should be more than 3. For the time which is less than negative half, we will ignore because logically we don't have negative range of the time. So the time should be more than 3. Alright, so we must know how to apply the time, which is always positive. Okay, so let's see number 2. A particle moves along a straight line and passes through a fixed point O. Its velocity v meter per second is given by v is equal to t squared minus 8t plus 7, where t is a time in second. After passing through O, find the instantaneous velocity in meter per second of the particle when the t is equal to 3. So we just substitute t equal to 3 to find the v, and the v is 3 squared minus 8 times 3 plus 7. So we will get the answer which is negative 8 meter per second. Okay, the first question is just substitute. So the instantaneous velocity is negative 8 meter per second. For B, when the particle stop, of course the velocity will be 0. Okay, so we will let t squared minus 8t plus 7 equal to 0. and then we will try to solve the t after factorize. So the t is equal to 7 and t equal to 1. Okay, so determine the range of values of t in seconds when the particle move to the left. When the particle move to the left, the v will be less than 0, right? Okay, so we will try to factorize and then we will sketch the graph. Okay, t squared minus 8t plus 7 less than 0. So let's factorize, and after factorize, for the quadratic function we need to sketch a U shape, and less than 0 is the middle part of the quadratic function. So we actually want to focus to the time. The range of time is continuously, right? So the time is from 1 to 7, between 1 to 7 seconds, right? So that is how we read the range of the time.